Okay, let's move to section 2.2, reducing fractions. So everything we did in part 1 and part 2 has set us up for this, for reducing fractions. Now, what we want to do now is look, because in the past, this is what, hopefully in this course you're going to learn that things that we've done in the past that didn't work are going to work better for us now. So, let's look at this. And I've asked students, and I said, okay, reduce this fraction. And students jump out, oh, that's 1 over 2. And that's okay. And then sometimes I'll do a little larger one. What about that? Oh, let me think. I know 2 goes into this one 4 times, and then 2 goes into this one 6, and then 2 goes into that 2, 2 goes into that 3, 2/3. Now notice, we just stepped up one level with trying to reduce fractions, and look how much effort that took. And a lot of times students are scratching and writing and doing all kinds of things, and we just took 8 over 12. Now what if we look at something like this? What if we jump up to 12 over 50? And by the way, this is on page 95 of the book if you want to see this specific example. Let's look at 12 over 50. Well, students, again, they do the same thing. They're scratching, there's I don't know. So we're going to get rid of that. So with our prime factorization now in play, this is how we're going to reduce fractions. This is really cool the way this works out now. So what you're going to do starting now is you're going to take the numbers and you're going to prime factor both. So let's do 12 and 50. We're going to prime factor these two. Go back to what we learned in the last section, 2.1. Let's start with 12 first. We always remember, kind of a recall, write down some of our prime numbers. We always start with 2. So does 2 go into 12? Yes. 2 goes into 12, 6. Then we continue with 2. Remember, we continue until we exhaust it. 2 goes into 6, 3. We've reached a prime number. We can stop. So we know 12 is prime factored to 2 times 2 times 3. Then we'll do 50. Does 2 go into 50? Yes, this is an even digit. So 2 goes into, remember our scratch method? 2 goes into 5 2 times. Scratch it, 1 left over. 2 goes into 10 5 times. We have 25. We try 2 again. 2 doesn't because this is an odd number in the ones digit. So now we try 3. Well, 2 plus 5, we've exhausted 2. 2 plus 5 is 7, which is not divisible by 3, so we can move on. 5 goes into 25 5 times. We've reached a prime number. We can stop. So we know now 50 is 2 times 5 times 5. So now that we've prime factored the two numbers, this is the piece that's important that we got from the last section. Now we can reduce this fraction pretty efficiently. So 12 is 2 times 2 times 3, and we'll put that on top of 50, which was 2 times 5 times 5. And then you just identify the factors that are the same and cancel them. These two 2's can go away. There's a 2 and a 3 and a 5 and a 5, so that has to stay. So then we remultiply these together. 2 times 3 is 6. 5 times 5 is 25. 6 over 25 is the reduction of 12 over 50. And notice our new method allows us to do this very efficiently. Okay, let's look at another example. This is on page 96. We'll look at example 1. Example 1 is 42 over 70. Remember, in the past, this might have caused us some pain and anguish, but not now with our new method. Our new method allows us to do this very quickly. No more scratching, no more wondering, and this is very efficient. We're going to take 42 and 70, and we're going to prime factor both. Again, we'll start with 2. So let's start with 2. Does 2 go into 42? Yes, because that's even. So 2 goes into 4 2 times. Nothing left over, so I like to put a 0. 2 goes into 2 1 time. Try 2 again. 2 doesn't go into 21 because it ends in a 1 here in the ones digit. So we'll try 3. 3 goes into 21 7. This is a prime number. We're finished. So 42 is 2 times 3 times 7 prime factored. Let's do 70. Does 2 go into 70? 2 absolutely, because this is an even digit here. 2 goes into 7 3 times. That's 6. Scratch. 1 left over. from 7. 2 goes into 10, 5. Does 2 go into 35? No, because that's an odd number in the ones digit. Does 3? Well, 3 plus 5, let's try that. 3 plus 5 is 8, which is not divisible by 3, so 3 doesn't. So we move up to 5. 5 does because that ends in a 5. 5 goes into 35 7 times. That's a prime number, so we can stop. So 70 is 2 times 5 times 7. Now notice what we have over here. 42 is 2 times 3 times 7. 70 is 2 times 5 times 7. We look at the common factors and we scratch them out. The 2's and the 7's will go away. So 42 over 70 can be reduced to 3 over 5. So notice our new method of prime factorization helps us reduce large fractions very efficiently. Okay? All right. Let's look at another example here. Let me grab. Okay. So on another example, let's look at example 2. Example 2, we've got 120 over 132. Again, in the past this might have been very difficult for us. Not anymore. 120 and 132, we're going to prime factor those two. Does 2 go into 120? Yes, that's even. 2 goes into 12 6 times. Nothing left over. 2 goes into 0 0 times. Does 2 go into 60? We have to continue. Yes, it does. 2 goes into 6 3. Scratch. Nothing left over. 2 goes into 0 0. Does 2 go into 30? Yes, because this is even. 2 goes into 3 once. Scratch it. There's 1 left over. 2 goes into 10 5 times. Does 2 go into 15? No, because this is odd. One in the ones digit. So we move on and try 3. 3 goes into 15 5 times. We have a prime number. We can stop. So 120 is 2 times 2 times 2 times 3 times 5. Let's do 132. Does 2 go into 132? Yes, because it ends in a 2. 2 goes into 13 6 times. Scratch it. 1 left over. 2 goes into 12 6 times. Does 2 go into 66? Yes, because it ends in an even 6. 2 goes into 6 3. Scratch 0. 2 goes into 6 3. Does 2 go into 33? No. So we move up to 3. Does 3? Yes. 3 plus 3 is 6. So it has to go in there. So then we have 3 goes into itself once. Scratch 0. 3 goes into 3 1. 11's prime. We're finished. So 132 is 2 times 2 times 3 times 11. So now let's go over here. Okay. So 120 we know to be 3 2's, a 3, and a 5 as factors. We know 132 is 2 2's, a 3, and an 11 as factors. So then once we have that, we just scratch out the ones that are like. A set of 2's will go away there. A set of 2's will go away here. A 3 will go away here. And that's it. So what's left over is a 2 times a 5, which is 10, over just an 11. So 120 over 132 reduces to 10 over 11. So again, our prime factorization is allowing us to do these things much more efficiently. All right, one more example. Example 3. This is 60 over 210. And again, this can be done using prime factorization as well. So as you go through these, prime factor the numerator and the denominator, the top and the bottom. Does 2 go into 60? Yes. We actually saw it here, so we can revisit that. 2 goes into this 3, scratch 0. 2 goes into 30, 1, scratch 1. 2 goes into 10, 5. 2 doesn't go into 15, 3 does 5 times. We can stop. So 60 is 2 times 2 times 3 times 5. 210, 2 goes into it. 2 goes into it because of the 0. So 2 goes into itself once. Scratch 0. 2 does not go into 1. So you have to put a 0 here. It does not go into there. So you can scratch it and move the 1 over. And does 2 go into 10? Yes. 5. So this is an important piece here. I want to highlight this. When you get to this spot, if the number is larger than the number you're looking at, you have to put a 0 because it doesn't go into it at all. That's what the 0 is for. Then you can take that and move it over to the next place value, and 2 does go into 10 5 times. This is a very important thing. Put a star by that you make sure you keep it, because it makes sense that 105 times 2 is 210, not 100 excuse me, not 15 times 2. Sometimes I have students who will leave this blank and put a 15. 15 times 2 is 30. Okay, does 2 go into 105? No. Does 3? Well, let's see. 1 plus 0 plus 5 is 6, so 3 has to go into here. So 3 goes into 10 3 times. Scratch 1 left over. 3 goes into 15, 5. Does 3 go into 35? We talked about this a little bit earlier. 3 plus 5 is 8. It does not. We move up to 5. Does 5 go into it? Yes, 7. So this is a prime number. We can stop. So 210 breaks down to 2 times 3 times 5 times 7. Now let's go over here. We know 60 is 2 2s, a 3, and a 5. And we know 210 is a 2, a 3, a 5, and a 7. Now again, cross out the 2s because they're alike, the 3s because they're alike, the 5s because they're alike. So the only thing left on top is a 2, and the only thing left on bottom is a 7. So what we have then here is 60 over 210 reduces to 2/7. So what I want you to do is use your new prime factorization to help you reduce fractions of any size.